Okay, good morning all. Welcome to today's session. First of all, I will introduce myself. My name is Priyanka More and I am mobile application developer here in Mindbrowser. As we know, today we all together here to learn and know about what is Bluetooth low energy. So whenever we hear the word Bluetooth, what comes in our mind? Like so many gadgets in our daily life we use, like earphones, Bluetooth earphones, smartwatch, or many other Bluetooth devices. So but I will today we will introduce like what is Bluetooth low energy, how it works, and how we use in our real life. First we will see what is Bluetooth low energy. uh, can you change the slide, Bruno? Next one. So we'll see today's agenda first. What is Bluetooth low energy? Difference between Bluetooth low energy and Bluetooth Classic. Then prerequisites for BLE. Then we'll see how does BLE work and what are the real world uses of BLE. And we have prepared very interesting small demo by using BLE. Hope everyone will enjoy it. So first we'll start with the what is BLE. As we all know, Bluetooth is a wireless connection oriented technology. It uses low energy radio waves to send wireless data between Bluetooth enabled devices. Bluetooth low energy is based on Bluetooth and it was released in 2011, and it is also referred to as a Bluetooth Smart and Bluetooth 4.0, and we can call it like a lightweight subset of Bluetooth Classic. It works in short range, low power personal area network, and most important to know is BLE works on low power and transfer the smallest amount of data using minimum energy consumption. The difference is that BLE devices remain asleep in between connection. They are also designed to only communicate for a few seconds when they do connect. Switching off and on between transmission allow devices to communicate effectively at fraction of power, and it's not uncommon for BLE devices to last for a year long on a single battery. So this is the introduction of BLE, and we'll see what is the exact difference between Bluetooth Classic versus Bluetooth low energy. We'll see differences, like both are used for connect the devices and transfer the data for personal and commercial uses. The main difference lies how they are distinguish data from low energy power, and Bluetooth Classic used to transfer lots of data continuously but contains high power and more cost. BLE transfers smallest packet of data over short period of time using low battery power. Here, these are few mentioned differences by using their performance. We'll see one by one. Like first, we are considering point like transfer of data transfer rate in Bluetooth Classic. It's 2 to 3 megabit per second, and in Bluetooth low energy, it's 200 kilobyte per second. Then time to send data for Bluetooth Classic typically 100 microseconds, and for BLE it's typically 3 microseconds. As we know, it transfers very slow data. Then power consumption approx for Bluetooth Classic is 3 mA, and for BLE it's less than 15 mA. And so by considering all these points, which Bluetooth for which devices Bluetooth Classic or is suitable or Bluetooth low energy. So use case that need continuous streaming of data, like earphones, we use headphones. So we can use there like a Bluetooth Classic because we need continuous communication in between both the devices. But if we required we don't require streaming of data continuously, then we can use Bluetooth low energy. So Bluetooth and Bluetooth low energy are wireless and personal area network standards. Bluetooth low energy is developed to take care of sending small chunk of data. It's designed to run Internet of Things devices using coin cells. As we know, Bluetooth is used for network requiring data exchange as well as wireless headsets and other consumer devices. BLE is used for applications such as mobile payment, healthcare, ticketing, and access control devices. Both technology based devices are low cost. So these are the main differences, and these are the use cases we can consider while choosing Bluetooth Classic and Bluetooth Low Energy. So next we will see what are the terms and concepts present in BLE. When we start working with this, we may consider all these points. These are very helpful while looking with BLE devices. Here we will see in short. First, I will let you know what is generic attribute profile. Then we'll see generic access profile. Then what is profiles, attribute protocol, characteristics, descriptors, and services. All these concepts are present in BLE. We will see in more details one by one. First, we will see generic attribute profile. We can call it GAT. The GAT profile is general specification for sending and receiving short piece of data known as attributes or a BLE link. And all currently BLE application profiles are based on the GAT. Then what is generic access profile? GAT defines the framework for allowing devices, discovery, security, connectivity, and the related network technology. And it is thus mandatory for BLE devices. It defines our role, our connection may implemented or not in between our devices. Then we'll see profiles. Profile is a specification for how device works in a particular application. Device can implement more than one profile. For example, a device could contain a heart rate monitor and a battery level detector. So these are two different profiles for that particular device. So we can manage it accordingly as per our requirement. Then we'll see attribute protocol. This one is very important. GAT is built on top of the attribute protocol, and attribute protocol is optimized to run BLE devices. To this end, it uses a few bytes as possible. Each attribute is uniquely identified by universal unique identifier. We call it as a UUID. And so one question comes in our mind, like what is UUID? So UUID is standardized 128-bit format for a string ID used to uniquely identify the information. The attribute transported by AT are formatted as a characteristics and services. So we'll see what is characteristics and services. So characteristics are the lowest level concept in GAT transaction. It's a encapsulated single data point, and the characteristics distinguish itself by a predefined 16-bit or a 128-bit UUID. And then we'll see descriptor. Descriptors are defined attributes that describe a characteristics value. For example, descriptor might specify a human readable description, acceptable range for a characteristics value, or unit of measuring that specific characteristics value. And then we'll see the most important part, like services. Services are used to break data up into logic entities and contain specific chunk of data called characteristics. A service can have more or more characteristics, and each service distinguishes itself from one service by means of unique numeric ID called as a UUID. So by using UUID, we can identify which service we want to use, and accordingly we perform the operations on that. So what are the operations? We'll see. by and these are the concept present in BLE devices. I have introduced here in short, but when we will see the demo, you will get more idea about all the terms and concepts. Before that, we need to understand what are the operations, so that we will understand all the things very properly. So I will first let you know what are the operations present in BLE. So read, write, notify, and indicate, all these operations present in Bluetooth Low Energy. First, we'll see read. When we want to use the read, we need to enable it, and once we are able to enable read operation, we can read the characteristics values from BLE devices. Then second operation is write. We can write in two ways, like write with response and write without response. When we write with response, the characteristics value also get acknowledgement from the BLE devices after operation completed. And if we write without response, in that case, the characteristics value will not get any acknowledgement from BLE devices, like we have written or not, we can just perform that operation. But if we write by using with response, then we will get acknowledgement from BLE devices, like you have written something on your BLE device. Then notify and indicate. The notify and indicate both mostly work same, means it gives it continuously gives changing data of our BLE devices. But the main difference between notify and indicate is when we enable the notify, notification does not require any acknowledgement by the client. But if we enable the indicate, indications do require the acknowledgement from the client, like when we are getting data, we need to acknowledge that I'm getting changing data continuously. So these are the main concepts.
So now I'm going to explain about the gap roles. The basically gap roles defines for like the connection oriented purpose. And so gap role we can define that gap roles based on two ways, like for connectionless and connection oriented. So connectionless we can only consider as a broadcasting purpose, and connecting we can connection oriented we can consider as a bidirectional purpose. So now I'm going to explain about first broadcasting or connectionless devices. So in that there is a two kind of devices. First one is like a broadcaster, and second one is the observer. So a device in broadcaster role, they does nothing more than transmitting data to its surrounding, means it's only advertising the data to the nearby radius. So and it periodically sends the advertising data packets to the nearby observer and any other kind of devices. And it does not enter any kind of connection, and it does not hold the connection. And the second device is like observer. It only scanning the devices and scanning the packets which are transmitting by or advertising by the broadcaster. It does not need a transmitter, and it sends nothing, and it's never mean to enter connection. So it's only for like a display purpose. So we can consider example of like receiving location or identity information from broadcaster, and only need to display it in the screen or whatever we have to display. And now second role is like connection oriented or connecting we can consider. In that there are two kind of devices. There is one is peripheral devices, and the second one is central devices. So now I'm going to explain about the peripheral devices. The peripheral devices are the low power energy devices, and that can be scanned by the central devices. And the peripheral device is advertising itself, and they containing the meaningful information which the peripheral device holds. After when connection is established with the central devices, it acts as a slave, and only one the peripheral device can connect with only one central devices. If you want to change, you need to break connection with first central device, and then you can connect with other central devices. The peripheral devices are typically low power energy, so we can consider the example like smartwatch, smart fitness band, any other like heart rate sensors, smart LED bulbs, industrial machine sensors. So, and now the second part is like central devices. Central devices are the high power energy devices like our mobile, laptop, tablets, or any other kind of machines. Central devices, they are scanning for the peripheral devices, and it gather all the meaningful information from the peripheral devices, and they will try and put logic into it and display to the client side, means client mobile or laptops, and it also storing the data wherever we have to store the data, like in AWS or any kind of database, and we can mostly perform operations from here. And after connection established with a peripheral device, it act as a host, so it's controls the peripheral device and do whatever they want to do with the peripheral devices. So now I am going to explain about how Bluetooth low energy works. So I explained in like three ways. First with attribute and data hierarchy, then second with central and peripheral communication, and the example service, third parties. So now I'm going to explain about like how the attribute and data hierarchy works. So as previously Priyanka said, like get means a generic attribute profile. So it defines the way how Bluetooth Low Energy transfer data and forth and back to the connected devices with like services and characteristics. And for the get, when it's come into play, we need dedicated connection with like central device and peripheral devices. And the most important thing we have to keep in that, like get and connection is there, they must be exclusive. And now going to explain about like attribute and data hierarchy. So first one is the profile. So profile means it's a group of services which contains the meaningful data, and like heart rate service or any other kind of services, and they are compiled by the Bluetooth SIG or peripheral designers. And now second part is services. Services are a group of characteristics. They broke up into logical entities like characteristics. They have services have more than one characteristics, and services has a unique UUID ID. So we can identify uniquely to particular services, and like many services like heart rate service and other kind of services. The second part is third part is characteristics. Characteristics is the low level part of the particular data hierarchy or attribute, and it contains the proper descriptors and values and related things. Now I will explain like in real example, real life. There is a group of Tata. So group of Tata is like a one profile. They have many services, like they have car services, they have airport services, they have tea or coffee services. In that they have like multiple characteristics, like they have, if they have airport, they have national airport, they have international airport, they have, means if there is a car there, LRJ means Land Rover and Jaguar and Tata cars. So these kind of things we can match with a real world example, and the characteristics has properties and values and permission also. And now I'm going to explain about central and peripheral communication. So here this is the example of central devices, and this is the example of peripheral devices. So central devices, as I explained, they are when our Bluetooth or connection permission available, they are scanning for the request, means they are continuously scanning for any advertising data, means for the by the peripheral devices, and peripheral devices, they are continuously advertising their data, means our laptop or mobile have Bluetooth connection, and so after permission, after we give permission, it will scanning the request for the request, and like other smart watches and smart keys, heart rate machine, smart home concepts, things like smart bulb, smart light, AC. So, and the main thing is like BLE technologies act as a middleware. So whenever we scan the request and advertise the date, peripheral advertise, after the connection established, we can perform read and write operation, which Priyanka said previously, read, write, notify, indicate operation between the this kind of two devices. We can perform the, means if we have like a smart home, whenever any kind of things happen in emergency, like any kind of fire things happen, means aag lag jaye, or heart means in heart rate services, if our suddenly heart rate increasing and this kind of thing, they will indicate to the laptop or mobile, means central device, and so we can perform operation and we can put alert in this also. And now there is an example service, means this is the example of like a heart rate service. So in that there is a four attribute like handle, UUID, permission, and mail use. So and here also service has two characteristics here. So handle is a unique UUID, we can consider it doesn't change, it holds the unique value, and there is a UUID which contains the service UUID, characteristics UID, profile UUID, and the third is like a permission. Permission is like some characteristics have permission, like read permission, write permission, means some permission doesn't want to share data, so it has non permission, and some permission also like indicate, notify permission also. Attribute value, so it's a human readable value which contains the metadata for the particular characteristics also. So now I'm okay. How we can use the BLE in real world? So we can. There are some cities or there are some areas in which BLE technology is really works, and in future we can also use the BLE for our personal and professional use in the future. So first one is like a wireless charging. The one company, who has established Resonance, the company name. They transfer the energy using the BLE technology. So we can transfer the charging from one device to another device. And the second part is like medical service. So there is a blood glucose and the blood pressure meter, they reports over the BLE technology. So whenever any kind of situation happens, like blood pressure increase or decrease, we can properly identify the data, and we can alert the medical service or any medical dispensaries. There is a smart kitchen, we can use BLE. So in smart kitchen, they helps. There is a smart fork we can use, and it helps to you monitor and track your eating habits for like any kind of things like weight loss and medicine. If you have any kind of disease, so we can keep and track of our food data. And there is a like a smart text also. So in smart text, we can there is a small tile of things which we are like in airport, and when we are going to planning a trip, so we can keep look at our data with our bags and related like packages. And there is another like track pets behavior. So we can track our if you have a pet like cat or a dog, so whenever they lost, we can identify them properly. And in automotive industry, like currently the Tesla and other electric cars are also, so we can also use for like wireless charging car and uh, other related things. And so, and there is a home automation system like a smart bulb, smart AC. In that also we can use we can consider a smart city. We can properly turn off and turn on the bulb or any kind of other devices which we are using in our home. Uh, the BLE is the, like, we can consider as a future, and it also works with IoT and related things. So it will helpful to us in the future. So now I'm going to show demo. Uh, uh, we have took the React Native platform because I'm a React Native developer, and I will also explain about how it will work with React Native, and I will also show how it's work with any other things. Okay, yes. So now I'm going to show you the demo. Means how we can connect the one central device, which is my mobile device, and one is peripheral. So first of all, let me give some information about library and what kind of device we are using. So in React Native, we use the React Native BLE Manager library because it's very useful, and it's providing many kind of services to us like read write operation which we can perform uh, to the peripheral devices. And we are using the Mansa app smart bulb for this demo. And now I'm going to explain how BLE works and related things. First of all, I will show you demo, and then I will give some basic and overview information and in the flow chart, so everyone can understood. So first I'm going to show you the demo. So now, first of all, we are um, scanning for, means we are checking the permission for the Bluetooth for our in our central devices, means in mobile. So whenever we allow this, we have permission. So now it's scanning for the nearby peripheral devices in our particular radius. So currently there is a one devices connected with my central device, which is the smart bulb. So, and here we can also refresh, means also we can scan the particular data again. And now our one peripheral device, means smart bulb is connected with our mobile device. So now second part is we have to connect our currently devices scanned. So first of all, we have to check connection with that particular devices. So now we are going to connect that device, and then we can perform the read write operation with it. So now I'm going to connect device. Currently devices, we have checked like device is connected or not. If not connected, then we are going to connect again because we have to perform the read and write operation. So currently now there is, we can perform the power on and off operation to the BLE to the peripheral with smart bulb device. So now this is the switch through which we can turn on the bulb and turn off the bulb, which we are regularly doing by power switch. So now I'm going to off the switch. So currently the bulb is turned off, and when I going to switch on, this is currently power is on. So, and we can also perform this is the smart bulb, and it has like color of device color. We can change the color of that particular bulb. So now currently I have this color picker. So currently I'm selecting this kind of service color, so it will change the bulb color, and I am going to select this color, so it will change the bulb color. And the other color I am choosing, like here is like green kind of, so it's also changing the color. And now we have also provided the shades with a particular color, like there is a gold color, and there is a khaki color also, and there is a light yellow, there is a purple shade also, like a purple palm lavender color, and there is also a red color shades also, like red, dark salmon, and there is also orange color, and coral orange red. So green shade also here I am providing, like green color also, palm green, and there is a blue shade also, like blue, steel blue color. Okay, and here I also uh, provided the uh, to the how we can change. And yes, for read and write operation, we have to convert into the particular like by for write operation we need the transfer the our data into like byte array as per the hardware requirements. Sometimes it's changed because currently I have to change in byte array, and sometimes it's changed based on the our hardware or peripheral requirement. So currently I also renamed the device, like here is a smart bulb 1. I am going to rename it smart smart bulb 1. Okay, so I am renaming it device, and whenever I rename, we can also perform the read operation from that similar characteristics. So currently it's renaming the device, and now I'm going to show you means I give smart bulb 1, I perform the read operation, and then it again set the device name to the header. So now I'm going to explain in code also, uh, not in code, sorry. First I will show you the graph for that particular devices. So first of all, we have a central devices and a peripheral devices. So first of all, when peripheral device, I told you that it is advertised in, and in central device, first of all, we are checking permission. Means I show you in in the black, they are checking for permission. If we have permission denied, we can do nothing. If permission granted, and directly we can start the scanning. And after scanning, we are checking for connection if any connection is available or not. And whenever, and it has two part, like connection failure or connection established. After connection is failed, we can do nothing. The device is already disconnect or failure operation is performed. And after the connection established, we have to find for discover services. uh, Means the peripheral devices, how many services and how many characteristics that peripheral or smart bulb has, or any kind of other devices like smartwatch and heart rate monitor services. And after getting the services from that peripheral, we have to match and identify the particular services. Means if we want to change the bulb color or if we want to update any kind of value, we need the particular services need to be available in peripheral device. So if we don't have any like we get those service but it doesn't have the required services, then we have to show that this device is like it's broken or is defective base we can consider. So we have to so we need the particular services, and after the service is found, we have to discover the characteristics for that particular services. And after we got the all the characteristics, we have to find the particular required characteristics as same as like services, because characteristics is the main value to read perform the read and write operation or notify operation. So it's a basic it's a required logic or characteristics we can consider. So after the, if we don't have that particular characteristic, we have to show that this characteristic is not available. So and other thing is like when our characteristics found, we can perform the read, write and notify operation with the particular peripheral devices. As I means I read the operation of like getting the bulb name, and the write operation I change the bulb name and the uh, right, and also change the bulb color, which is the write operation. So now I'm going to explain how it will work in code with the React Native platform. So first of all, as I told you, like we used the React Native Layer Manager library to connect the central and peripheral devices and to perform this demo. And we use the Mansa Smart Bulb to perform the, and we also use the color picker to change the display color for that particular bulb. So first of all, I'm going to explain like this is the method how it will work in React Native. This is method provided by the third-party library React Native Layer Manager. So first of all, we have to initialize the BLE technology, and first of all, and then we have to check for a Bluetooth permission for the central devices. So this method works. So Then based on the platform version of the particular, currently I have performed for Android. So this is permission we have to check the Bluetooth permission, and then we have to enable Bluetooth. After then we have to enable the Bluetooth, and if we give the positive permission, then we have to start scanning for the BLE devices, and we can, here this is the scan method. Here we can provide the UUID, means we can implement a filter also. So if we previously connected device, so we can again, it is helpful to find again them with that particular UUID, and we can also set the seconds in number. So for how many times we have to scan for that particular devices, like uh, if you want to like find for 10 second and 20 seconds. So in the second part, when our connection is established, uh, yes, and then we have to show the uh, okay, this is the method, list method to show the particular bulb services, and here we are going to show the list of connected device with our central devices, and when we are clicking on that particular single bulb or single peripheral, we have to check, like first of all, as I said, like we have to check it is already connected or not. If it's not connected, we have to connect it again, and then we have to redirect user to the other screen. So this is the method. So whenever we are navigating the user to the next screen, so first when we come into next screen, as I said, we have to find for the particular services. We have to get all the services which is provided by the peripheral devices. So current, this is the method, retrieve services method, uh, through which we can find all the services for that particular peripheral devices by the ID key. And then we in that also we can also identify the characteristics also. So here this is the logic I have put to, means we need this double FB0 services to perform the right operation for that bulb. So, and here I also find matching the characteristics, like to change the bulb color. Yeah, yes, these characteristics we need to change the bulb color. Yes, and then we can perform the read and write operation also. Yes, we can also perform the read operation, and currently we are getting the array, means a byte array from the library response. So we have to convert into the human readable format, as I said, like smart bulb one. So it's based on the requirements, it can be changed. Okay, yes, yes, okay, uh, this is, yes. Yes, this is the method, means how we can change the bulb color. So whenever we have to check that the particular service and characteristics available to change the bulb color or read or write value. So we are checking it, and we have to convert a particular X color code into the RGB format, and we are uh, transferring that with the full brightness value is, we have to transfer the byte array to write the value for that particular peripheral, and we have to pass also the RGB value uh, to the peripheral device. Okay, here we are read and writing objects. So first of all, we are again checking that peripheral is connected, or because peripheral, if there is an electricity of it will not connected. So we have to check connection with it, and if they are not connected, we are going to again connect with him, and then we have to write that characteristics. So for write characteristics, we need the particular this method. Through this method, we are going to write we are going to perform the write operation. So in that we need the ID of that peripheral device service UUID, for that peripheral characteristics UUID, and the write value means, as example like I have given. So it will turn off the bulb. So, and yes, we are also performing the bulb toggle on and off value, and in which we have to like pass the black color with 0 brightness, so it will turn off the bulb, and full brightness with 1 with the RGB value of 255 means white color, so we can also turn on off the bulb. And sometime based on the requirement, like if you want to change the, yes, yes, when we are renaming that device, as I shown that mobile devices, we are again checking for that it is connected or not, and also we have to connect with the, after connection is yes, based on the current we have Mansa device, so it requires the 19 character write value to perform the write operation. Currently, I have added the space if we don't have 19 characters value. So for demo purpose, based on the client requirements and our requirement, we can also change it. So this is the example, means how we are performing the read write operation, and how central and peripheral device can connect with which each other and perform. We can do the things which we want to require.